Hello everyone, welcome to Ramaila Padai. Today we are going to solve a question from Unit 6 Sequence and Series that was asked as question number 8 of SE 2080 Bagmati Province, and the question says that a table tennis ball is dropped on a wooden board and returned till the height of 1024 mm in the first bounce. So tennis ball was dropped and it reached to the height of 1024 mm in the first bounce. Is that okay? Okay. Now the ball bounced just half of the preceding height continuously. That means if the ball was bounced up to height h in first bounce, then in second bounce the height will be h by 2. That means height is decreasing by half. Okay, you got it. Now in A, in which series the above context can be expressed? Write it as the height decreases by half of the preceding height continuously. That means the height is decreasing with ratio of 1 by 2. I mean to say is that the second height by first height will be 1 upon 2. So this will be geometric series. Is that fine? Okay. In B, what is total distance of heights the ball may reach till the fifth bounce? So for n is equals to 5, that is fifth bounce, find the total distance. That means you need to add height of first bounce, height of second bounce, height of third bounce, height of fourth bounce, and height of fifth bounce. So this will be S5. Okay, and we have formula for geometric sequence. S5 is equals to A 1 minus r power n by 1 minus r. Why 1 minus r? Because since r is equals to 1 upon 2, which is less than 1, because 1 upon 2 is equals to 0.5. You got it. Now in C, find all mean heights between first and fifth bounce. What I have told you in the concept video is that there will be first term and there will be last term denoted by L. Here they are asking us to find mean heights between first and fifth bounce. So this is first bounce and last bounce will be fifth bounce. Okay. So mean heights between A and fifth is 3, because second, third, and fourth, and then we will get fifth. Okay, so we need to find these heights. To find this, we will use the formula of Tn is equals to A r power n minus 1, because this is geometric sequence, so we will be using this formula. Okay, it is quite easy. For first mean height, it will be n is equals to 2. Here n is equals to 2. Here n is equals to 3. Here n is equals to 4. This is how we solve this question. Okay, without any delay, let's start the solution. Okay, here height at first bounce, that is A, is equals to 1024 millimeter. Okay, now as ball bounce just half of preceding height continuously, its ratio will be 1 by 2. We will write that as the ball bounces just half of the preceding height continuously, the common ratio r will be r is equals to 1 upon 2, which can also be written as 0.5. okay, you understood this. Now let's move on to question number A. In A, in which series the above context can be expressed? As the ball is bouncing with common ratio, the above the above context can be expressed in geometric sequence. So this is solution of A. Now moving on to B. Let me just draw a border here so that you won't get confused which is solution and which is just explanation of this question. Okay, now moving on to B. What is total distance of heights the ball may reach till the fifth bounce? Let the total distance of heights that the ball may reach till fifth bounce be yes 5. Okay, we have, what do we have? A is equals to 1024 millimeter, r is equals to 0.5. Now what will we need? Okay, this is what we need for to find S5. So now using formula, S5 is equals to A 1 minus r power n upon 1 minus r. Why? Because since r is less than 1. Okay, so we need put the value A as 1024, 1 minus we have r 0.5, and we have n as 5. Okay, by 1 minus r is equals to 0.5. Let me just solve this. 1024, 1 minus we have 0.5 times 5 is equals to 0.3125. 0.3125 upon 0.5, which is equals to 1024 times 0.96875 divided by 0.5 is equals to, what we have, this multiplied by 1024 and divided by 0.5. 1984 millimeter. So we will write that in language. So the total, let me just save this so that it will be quite easy to write. So the total distance of heights that the ball may reach till the fifth bounce is 1984 millimeter. Okay, so this is it. Now moving on to question number C. Find all the mean heights between the first and the fifth bounce. Here the three mean, as we know there will be three mean heights, as I have explained you here. Here the three mean heights between the first and fifth bounces B. So we will write a sequence. Here we have A, we have M1, we have M2, we have M3, and we have last term L or T5. Okay, so this will be the sequence. Now we will find M1. Now M1 is equals to, which is also T2 second term, is equals to A R 2 minus 1 is equals to A. We have A as 1024 times R is 0.5 times 1, which is equals to 512 millimeter. Okay, now we will find M2. M2 is equals to, which is also third term, is equals to A R 3 minus 1. So A is 1024 times R is 0.5, and we square this. 3 minus 2 is equals to 2. So 0.5 square is equals to 0.25 times 1024 is equals to 256. So we have 256 millimeter. Now we will find third mean, which is fourth term of the sequence, and the formula is AR 4 minus 1 is equals to 1024 times 0.5 power 3, which is equals to 128 millimeter. Okay, so the mean heights between the first and fifth bounces are 512 millimeter, 256 millimeter, and 128 millimeters respectively. So this is about the solution of this question. If you have any confusion, please let me know in the comments section down below, and we will meet you in the next video. Till then, bye bye.